Hello and welcome to Lab 5, where we will cover a review of factoring. In this lab, we're going to look at a couple different factoring methods, the first of which is prime factorization, which means we want to take a number and decompose it into a product of prime numbers. You may recall from previous math classes that prime numbers are numbers like 2, 3, 5, 7, etc., numbers that can only be divided by 1 and themselves. To do so, we're going to take the initial number, like for this example, we'll start with 48, and split it up into two numbers that multiply to be 48. They don't necessarily have to be prime yet, but we're going to keep breaking it down until we get to the prime numbers. So for example, 48 could be 4 times 12, or 6 times 8, or 2 times 24. Let's use 4 times 12. You could use any pair. Here, 4 and 12, neither of them are prime, so I will continue to break down these respective numbers until I get prime numbers. Like 4 can be broken down into the product of 2 times 2, where both of these numbers are prime. So I circle them to indicate that we are finished with that branch. For 12, I can break that up into two numbers. We could do 3 times 4, 2 times 6. If I do 2 times 6, I notice that 2 is prime, but 6 is not, so we can break 6 up again into a product of 2 times 3, where both 2 and 3 are prime. So in this case, we can write the prime factorization of 48 as the product of 2 to the 4th power times 3. And those are both prime numbers, 2 and 3. And those are all I have, and then when I multiply them together, I get 48. So that's the prime factorization. Now, the factors you use, like we said, 4 and 12, or 2 and 6, can be any numbers that multiply to be the number ahead of them in the tree. When we start factoring polynomials, we have some different methods. This next example is a trinomial, or a polynomial with 3 terms. And the first type of factoring we have, and that we'll always look for, is to factor out the greatest common factor from each term. Like you notice that each term here has a factor of 9, like 9 can go into each of the 3 terms. They each also have an x, and they all have a y. So we're going to look at those pieces, put them together, and pull them out, one from each term. 18, 9, and 9, the biggest number they share, the greatest common factor of them is 9. They all have an x in them, just one x. But the y's show up a minimum of 3 times. So you see that this one is third, then I have 4 y's and 5 y's there, so I can take out at least 3 from each term. Then what I'll write is what remains after I factor this out. So I'm taking 9xy to the third out of each factor. That leaves me with 2y squared from the first term. I have 1 from 9 divided by 9, and y to the 1 power from y to the 4th over y cubed. And then from the last term, that's exactly equal to my GCF, so I just write a 1 there as like a placeholder. And then you can notice, of course, if I were to distribute back through here, I would end up with my non-factored polynomial, the example. So that's the first method of factoring. It's called removing or factoring out a GCF. Second method we have is called factor by grouping, where you look at these 4 terms of the polynomial and notice that all 4 of them don't share any common factor. But what we can do is split it up into like groups of 2, or factor it kind of by pairs, if you will. That's the grouping part. So we look at the first 2 terms of the polynomial and take out a GCF from those 2. Like for this example, 5xy and 15x both share a 5x. The part that remains once I factor out that GCF from just these 2 is a y and a negative 3. From the next pair, I can factor out a new GCF. So I have negative 6 and positive 18. Both of them share 6. And we'll take this sign, and so we'll use negative. What is remaining when I take out a negative 6 is going to be a positive y, but a negative 3, since negative 6 times negative 3 makes a positive 18. Once I factor it in this way, you might notice that the first term has a y minus 3, and the second term has a y minus 3. So we can factor that out together as a GCF, y minus 3 And that leaves me with the remaining two parts, 5x minus 6, kind of the leftovers, if you will. So now I factored this polynomial with 4 terms with a method we call factor by grouping. Another method we have exists for polynomials that we call trinomials, where they have 3 terms and they're of this form, x squared, an x term, and then just a number. So this is of the form we call ax squared plus bx plus c. You'll notice that in this case, the a, or the coefficient of the x, is just a 1. And those are the easiest type of trinomials to factor, because we know that when we have something where the a is just 1, we must have some kind of product of what we call binomials. So we must have like one polynomial here times another polynomial, where the form of the answer is going to be like x times x plus or minus some number here and plus or minus some number there. We want to find those numbers, so you maybe remember that we want to find numbers that will multiply together to give me the c term and add together to give me the b term, or the middle term. So I want two numbers that multiply to be 8. I've seen people write it like this. Perhaps you remember this. But one number times another number needs to equal 8. And one number plus the other number needs to equal the b term, or negative 6. So then you can kind of like run through this and think, all right, 8 is 2 times 4, but 2 plus 4 gives me positive 6, and I need negative 6. So what if I change the sign here? Negative 2 times negative 4 still equals positive 8, but negative 2 plus negative 4 equals negative 6. So just kind of messing with the signs there, I can find the n terms of these binomials. And once I find two numbers that meet those criteria, I can put them in the binomial, and I have a factored polynomial. Of course, you can always check it by multiplying back, or what some people call FOIL. X times x makes x squared. X times minus 4 is minus 4x. X times minus 2 is minus 2x. Minus 2 times minus 4 is positive 8. I can combine the middle terms, those are like terms, for minus 6x, and I end up with the polynomial that I started with. X squared minus 6x plus 8 equals x squared minus 6x plus 8. So that means I have the proper factoring, but remember our solution is going to be the factored polynomial. Okay. For example D, we have again a trinomial. It kind of looks like the one we just did in example C, but we notice that there does exist a GCF, or a common factor, for all 3 terms. So the first thing we need to do is factor that GCF out, or take it out of the polynomial, and then see if we can continue to factor from there. The greatest common factor for all 3 of these terms is 3x. You may notice that each term can be divided by 3 evenly, and each term can be divided by x evenly, so we take them both out. What remains from the first term is simply x squared. The next term gives me minus 10x, and the last one is plus 9. Once I take out the GCF, which I've done in green, I have this remaining polynomial, or a trinomial, in blue. I need to factor that completely. So now I notice that this is of the form ax squared plus bx plus c, where it's a trinomial that can be factored into the product of 2 binomials, where I have x times x. I need 2 numbers that multiply to be positive 9 and add together to be negative 10. So another way you can look at this is find factors of 9, like 1 and 9 and 3 and 3. When I add them together, see what I get. 1 plus 9 makes 10, 3 plus 3 makes 6. And I want those things to add together to give me my b term, or my middle term, which is negative 10. So that's kind of my goal. I notice that I do have 10, so I can look back at my factors here and see if I can make 1 and 9 together to add up to be negative 10. And in fact, I can if I make both of them negative. And we'll check that negative 1 times negative 9 makes positive 9, and that's true. So those numbers become the end parts of these binomials. X minus 1 and x minus 9. And I remember to bring down my GCF. So now I have a polynomial that is factored completely. Of course, you can check it by FOILing those two binomials and multiplying everything by 3x to make sure you get the polynomial you started with. The next example is similar. We don't have a GCF here, but we do want two numbers that add to be 25, or excuse me, multiply to be 25, and add to be negative 10. Factors of 25 are 1 and 25, and 5 and 5. And when I add them together, 1 and 25 together make 26, 5 and 5 together make 10. So I'm looking for the end parts of these binomials. The middle part I want is 10, so it must be this pair, this situation. But I need a negative 10. Remember, this is negative. So I must have negative 5 and negative 5. Since negative 5 times negative 5 still makes 25. That means the end parts of these binomials are negative 5. And that happens twice. So what we can do here is recognize that this is the same thing multiplied by itself, or we can rewrite it as the product of a or rewrite it with exponents, x minus 5 to the second power, or squared. This type of polynomial is called what we call a perfect square trinomial. The next example is similar, but you may notice that the middle term is missing. So now I have x squared minus 25. These are our favorite types of things to factor because they're the easiest. They have the general form of the trinomial, just that the b term is missing. And so what we can do with this is take the first term and split it up. So x squared is the product of x times x, and 25 is the product of 5 and 5. Since the first one is squared and the second one is squared and there's no middle term, I have something that looks like this. And then the inside parts are opposite. So I have one positive and one negative. This is called a difference of squares. And we love factoring these type because they're very easy to do. We just split up the first term, we split up the second term, and then remember that we have a plus and a minus for each of them. You might want to note, though, that when we have the sum of two squares, like x squared plus 9, that this polynomial cannot be factored, and it is what we would call a prime polynomial or non-factorable, because there are no two binomials that we multiply together that will give us this polynomial. Just try it out if you don't believe me. The next examples are where we kind of pick it up a notch. This is still of the form ax squared plus bx plus c, but you'll notice that the first term here is no longer equal to 1. And that makes our life a little more complicated. It has a general form, so we do have a binomial times a binomial, where the first term is the product of the first two terms here. So we make 2x squared, and the only way to do that would be to have 2x times x. So we can split that up. Now this last term, or the last part, you may remember, is still a factor of negative 6. It still has to multiply to be negative 6. So we're looking for something here and here that multiply to negative 6. But now when we FOIL this polynomial together, we want to get positive 11x in the middle. So the first method that we can try is called like guess and check or trial and error, pretty much just by what I would say brute force. Where we think of numbers that multiply to negative 6, we try them in the ends of these binomials and try to find a pair or a certain position that will give me positive 11 in the middle. Let's try to make negative 6 out of, how about negative 6 and positive 1. Those are two factors of negative 6. If I FOIL this polynomial to check it, 2x times 2x for the first gives me 2x squared. 2x times plus 1 for the middle term will give me plus 2x. The inside term will give me negative 6x. and the last term will give me minus 6. So these two terms, when I combine them, is negative 4x. Now remember, I was looking for negative or positive 11x, so I'm not too happy with this minus 4x. So let's try a new pair. I did negative 6 and positive 1. Maybe I flip those around and try positive 1 and negative 6 here. The first and the last terms of my foiling will remain the same. I just have to mess with the middle. So 2 times negative 6 gives me actually negative 12. X, and then the inside gives me plus x. Together, this makes negative 11x. So I'm getting closer to this middle term that I wanted, but I need it positive. So I'm going to switch the signs on these two. Instead of plus 1 and minus 6, I'll do minus 1 and plus 6, and then see what happens when I FOIL those out for my middle terms. So 2 times 6 is 12x, now that's positive, and negative 1 times 6, x makes negative x. So together, these two terms become positive 11x, which is what I wanted. So that means that these factors I have must be the correct factors. 2x minus 1 times x plus 6. And you can see that we got there just by making educated guesses for the ends of these binomials and then FOILing to check it out and make sure I get the right trinomial when I multiply. You know, that can be kind of tricky and also not very fun. It's a long method. So there is another method we can do, and we'll do that with h. Don't forget that the first thing you have to look for always is to check and see if we can remove or factor out a GCF. So let's do that here. We're going to remove or factor out by the GCF. Since we have a polynomial of 3 terms, but it appears that each of these terms can be divided by the same number, 2. And they can also be divided by x, so I can factor that 2x out from each term. That will leave me with 6x squared plus 5x minus 4. Now that I've removed my GCF, I notice that I have a polynomial or a trinomial of the form ax squared plus bx plus c. So I can expect that I have some binomial times some binomial. I just don't know what goes here. And if we were going to try the guess and check method, remember we have to split up 6x. But the problem with that is it could be 6x times x, or maybe I make 3x times 2x. And then have a lot of ways to make negative 4 do, like negative 4 and 1, or 2 and negative 2. So I would have like a lot of things to check if I do the guess and check method. So for this example, what I would like to do is use what we call the AC method. And that one is more methodical. So you have a plan. You're always getting closer to the answer. But it does have a couple steps that you'll need to practice and get familiar with. So let's enumerate those steps for ourselves, and we'll walk through that with this example. We're going to do the AC method of factoring. Excuse me. First thing we do are multiply the first and the last terms together. So what we do is multiply A times C. For our example, that would be 6 times negative 4, or negative 24. After we multiply A times C, we want factors of A times C that add up or sum to the middle term B. So I'm going to take negative 24 and factor it. Like I can do 1 and 24, I can do 2 and 12, I can do 3 and 8, I can do 4 and 6, and then those are all the factors of negative 24. I just put the negative on the last term just to see how it works out. When we add these together, I'm looking for something that adds to the middle term, or 5. And you'll notice that 3 and 8 together, if one is negative, make 5. But the way I have it is negative 5. And what I would like is a positive 5. So what we'll do is switch the negative signs on that. And instead of have negative 8 and positive 3, let's make it negative 3 and positive 8. So when we add them together, we get positive 5. That means that these two factors are the ones I want to use. I'm going to use them to split up the middle term. So that's my next step, is to split the middle, or the b term, into these two factors. So plus 5x will split up for me to be negative 3x and positive 8x. Because I still have 5x, I just split it up into be positive 8x and minus 3x. I'll bring down the rest of my polynomial here, 6x squared and minus 4. And I still have my GCF outside, 2x. Once I've split that middle term, I have a polynomial with 4 terms. So what I'm going to do here is factor that polynomial by grouping. It's kind of nice, we already learned how to factor by grouping, so now we just get to use it again. Remember, we grouped the first 2 terms and the second 2 terms, and take a GCF out of each pair. From the first 2 terms, 6x squared and 3x, I can remove a 3x. The part that was left over will be a 2x and a minus 1. From the next 2 terms, I can see I have 8x and minus 4. I'll take out a positive 4 from those two, since 4 is the GCF of those 2 terms, and I keep the sign of this number. So that leaves me with a 2x minus 1 again, and then don't forget that all of this is still multiplied by the GCF. To finish up my factor by grouping in here, I notice that 2x minus 1 shows up in both of those terms, so I can factor it out. And then I multiply by the leftovers, so that we had 3x and positive 4. And I bring down my GCF, which I factored out at the very beginning. So here I have factored this trinomial using the AC method. If I were to multiply it back together, I would get the same trinomial I started with. The AC method definitely takes some practice, so here are your steps. First, you multiply a times c. Second, you find factors of a times c that add to b. The third step is the one people forget often. They need to split that middle term up into those 2 factors that you find in your side work over here. For us, negative 3 and 8. And then the fourth step is to factor by grouping. But if you do that, you kind of save yourself a lot of time with the guess and check method, like we saw in example G. And you'll always end up with the right factors. You do it correctly, of course. So now you're ready to work on the worksheet. If you have any questions, take the worksheet to the math lab or ask your instructor. I'm sure they'd be happy to help you. And I hope you have a great time in intermediate algebra.